Okay. As we get started with this video, make sure you have your book open to page 377. That's the beginning of Module 9, Lesson 1. Make sure you have your foldable with you and a pencil, and you're going to need a calculator for this section. On your foldable, use the next two flaps. Label the first one measures of center and the second one measures of spread. Those are going to directly correlate to the examples in this section. As we read through this section, what I'm going to ask you to do is pause the video, read through, fill out the information, and then come back and we'll go through my notes as well as whatever you have down already. So I'm going to give you most of the answers, but it's important that you try to do it first on your own and then come back to the video for clarification. So this would be a good time. Pause the video and read through all of page 377, and then again flip over and do the reflection questions 1 and 2 on page 378. And we're back. So let's take a look. So this Explore section has bowling scores for Caleb and Kim, right? We have 3 different games, and we're asked to find the average scores for both bowlers, right? So we've got 450 is the total that you should have gotten for Caleb, divided by the 3 games leaves an average of 150 per game. Seems about spot on. Kim, on the other hand, has a couple weird games, 122, 139, and then 189 game. So she also has a total of 450, divided by the 3 games leaves her with an average of 150, right? How do their average scores compare? Well, they are equal, which is an important note. But let's think about the consistency of their scores. So Caleb or Kim's scores are more consistent. I put Caleb's because all of his scores pretty much are right on 150, whereas Kim has a 120 score in there and then 189, which is not consistent. Caleb's scores are farther or closer, I circled, to the average than Kim's. They bowl a 4th game where Caleb's score is 150 and Kim's score is 175. How does that affect the averages? Of course, the average for Caleb's going to be the same. Meanwhile, Kim, because she bowled another game above that 150 average, Kim's average is going to go up, right? And then we have our last question here, which says, does the Game 4 score affect the consistency of their scores? I said no, because Caleb is still consistent, right? And Kim is still not consistent. Kim goes up, but it's not really related to any of the other scores. All right. Let's take a look at the next page. So here we see 2 reflection questions. They're both discussions. Is the average accurate representation of Caleb's bowling? Yes, because he's bowling right around 150. It's not really that big of a difference. And then is the average accurate representation of Kim's bowling? I put down as a note, we don't have enough tools in our belt to say that it's inaccurate yet or why it's inaccurate, but we should be able to see that that's not a very telling statistic, right? While it is true mathematically, it doesn't necessarily tell us how Kim bowls. So let's keep moving on and add some tools to our tool belt. We're going to jump right into the first explain. Notice that the title is Measures of Center. So we're going to jump open our foldables to measure under Measures of Center and take our first couple definitions. All right. What do we have here? 2 commonly used measures of center for a set of numerical data are the mean and median. You should be familiar with these terms, right? Measures of center usually represent a central or typical value of a data set. All right. Our first measure is mean here. Make sure you get mean down in your foldable. That's the main definition we're looking for. And of course, a mean is the sum of values in a set divided by the number of values in the set. That's total divided by number of things in the set, right? The second term we have is median. Get down median in your foldable. And a median, of course, is the middle value in your data set. So the middle value in a set when the values are arranged in numerical order. So take a look at example 1, find the median of each data set. So they give you 7 numbers. First you total them up, divided by the 7, you get a mean of 50. And then when you order them, and this is an important note, notice that they are ordered from lowest to highest. The middle number, right, you can cross out those two, then cross out those two, then these two. The middle number left is 49. So the median is 49 messages per day. Again, example B, I know you can see it right there, but pause the video, go through it. So hopefully you paused and went through example B. Here we see that we're given a bunch of tips and we're asked to find first the mean. So the total number that I got for the tips was 835 divided by the 6 days that Elise works. It gives me $139.17 per day. That's the mean. And then for the median, I reordered her tips from least to greatest here in those boxes. And it came the middle, right? I take out the ends, and then again the ends. I'm left with this middle for the median, and I'm left with 2 numbers. So I want to take the average of those 2 numbers, which is 97 plus 100, and I'm left with $98.5 is the median number. And if we take a look at the other numbers that Elise got tipped, right? 98.5 seems to fall in line with 75, 97, 84, and 119 and 100, a lot better than 139, which is greater than all of the others, right? So what I want you to do, again, right here is pause the video and start on the your turn problems 4 and 5. All right, don't worry about the discussion problem, just your turn problems 4 and 5, and then we'll pick right back up. Okay, hopefully you paused the video and did those your turn problems. Remember, that's really what I'm going to be checking for homework the next time we meet. Now we're on Explain 2 on page 379, right below those your turn problems. Notice here we have measures of spread. So you're going to want to go to your next flap in your foldable, and we have a lot of definitions here. So leave yourself, hopefully this flap is large enough. If you have enough room on the other one, you might want to throw a couple of these in, but make sure you've got enough room under measures of spread for the next couple definitions, as well as you might want to get this example in right away so that you can have a reference in your foldable. So measures of spread are used to describe the consistency of data values. Remember, we said that Kim was not a consistent bowler because her scores went all over the place. This spread will tell us about those scores. So they show the distance between data values and their distance from the center of the data. 2 commonly used measures of spread are for a set of numerical data are the range and interquartile range. So our first definition, let's get range down. That's right here. And a range is the difference between the greatest and the least data values. A couple keynotes. We want difference here. We also want greatest and least. You might want to just highlight them in your foldable because those are going to be important. So the greatest value here we see is 9 and the least is 1. So we see our range is 8. Right? 9 minus 1 is 8. Okay. Our next definition is going to come from quartiles. And quartiles are values that divide a set into 4 equal parts. So if you can imagine all of the elements in our data set, we want 4 equal parts. Right? And then we're going to get directions on how to find each quartile here. The first one, the first quartile, or Q1. Get that definition right below the definition for quartile. All right, and that's the median of the lower half of the set. Highlight that. The median of the lower half of the set. Might want to underline. We've got median as a keyword and lower half, right? And then the second quartile, right, is the median of the whole set. So we need to think about this. We're labeling our set from left to right, right? Least to greatest, left to right. Then we are breaking up. First is leftmost. Second is the middle, right? And third quartile would be the upper half. So let's just label these again. So in your foldable, make sure you get in second quartile, right? And that's the median of the whole set. That's right here, right? And then finally, third quartile, get that in as well. And of course, that's going to be the median of the upper half. Median of the upper half. And I'm sure my notes here are now more confusing than your own foldable and notes. So please make sure you're taking good care. Pause the video and get all of these important definitions down once we're finished and neater than this video. Also make sure you get in, yellow, make sure you get an interquartile range, IQR, right? And that is the difference between the third and first quartiles. All right. In other words, third quartile minus first quartile gives us 4. It's the interquartile range that's in between these two guys, right? So at this point, let's move on and take a look at our first example, A. Right. It says the April high temperatures for 5 years in Boston are 77, 86, 84, 93, and 90. Really, I can't emphasize enough. At this point, read the question, and the first thing you should be doing is jumping right to this stage where you are labeling left to right, lowest to highest. All right. And then you can find a median by crossing out left, right, left with 86. Range, that's going to be greatest number minus the least number, right? Interquartile range, which we can see here. Right, upper half, we want the average there, lower half average here for the medians, right? This is finding an average. You only have two numbers, so you're going to pick an intermediate point, which an average will do. If you had three numbers, you'd choose that middle number, right? Finding these averages, and right here, interquartile range is the difference of those first and third quartile medians. So from here, the next page starts with example B, right? Take a second, read through that, try to do it on your own, and when we come back together, I will have those notes for you in an explanation. And we're back. Let's take a look at example B on page 380. All right, notice right away, first thing you should have done with the numbers from the example 1, understand you have 20 numbers. That's a nice little cue when you're asked to find the mean. The next thing that I did was order the numbers smallest to greatest. And then identify, of course, we have the lower half here. And of course, over here we have the upper half. All right, and I'm just letting myself know this. That'll help me with Q1 and Q3. Next thing I did was find a median. That was just by clicking off my outside numbers till I got to the inside. And when I did that, I found I had 7 and 8. The average, of course, is 7.5. The range, the least value minus the greatest value gives me 12, right? And then I'm looking for my interquartile range. That, of course, is a 4 for Q1. Q1 is the median of the lower half, and the median of the upper half, Q3, is 10. Right? And it's just a coincidence that both of those numbers, you have a 4 and a 4, and then a 10 and a 10. Right? It could have been 4 and 5. It could have been 10 and, in this case, they only go up by 1, so it could have been 9 and 10 or 10 and 11, but they just happen to be the same. And then we get the difference for the interquartile range is 6. So my data reads out the median 7.5, the range is 12, and the interquartile range is 6. To finish up this video, please make sure you answer the reflect question here as well as the next two your turns. And then I'm going to meet you on a different video link, which you can access in the outline for measures of spread standard deviation.